Hello everyone. This is the first chapter of this electrodynamics series, which is the vector analysis. So here we are. What is vector? Well, a vector is a mathematical object which has two features. One is its magnitude and the other is its direction. So a vector can be represented with this arrow, and the name of vector is A. Well, there are other way to represent the vector as well. Like this is the column form of vector, or we can say the column vector, or we can represent it in the row vector or the row form. Okay. But here we have to deal the vector with this arrow representation. Okay, we name this vector as a vector A. Okay, so if come to the addition of the vector, so the addition of vector will follow some rules. The first is the commutative law. The commutative law says that either we add A to B or B to A, the result will be same. So how we will prove it? Okay, we can prove it from geometrically. So how we will add two vector geometrically? Well, we can either use the triangle rule to add two vector, or we can use the parallelogram rule. So here we will add vector A with the vector B. So we have a this is the A vector, and we are adding vector A to the vector B. So this is the B vector. So we will just transport this A vector near the head of the B vector. So this is the same A vector just been transported. So the resultant vector will be this vector. This is, let's say, C vector. So C vector is is B vector added to the A vector. Okay, so we are just adding this vector first. Now we will do the we will do the LHS part. So again we have this A vector and we have B vector. So here we will add B to the A. Okay, so this B vector will be transported to the the head of the A. So this is the same B vector being transported, and the resultant vector will be this vector. This is the C vector, and when we look at this, this is the A plus B. This vector and this vector are same vector. Okay, so this is a proof that this A and B summation of the two vector commute. Come to the second properties of under the addition is the associative law. So either we will add vector A, and either we will add two vector A and B, and their sum will be added to C, or we can either take the A separate and add the other two like B and C, and their summation will be added to the first one, which is the A. In both the cases the result will be same. Okay, we can also prove this vector from we can also prove this identity from the geometrically. Okay, okay, what is the third? Well, the third properties is the existence of the inverse. So for every vector A there must be another vector B such that their summation will give zero vector. Okay, this is the zero vector. What is the zero vector? Zero vector is nothing but a point. Okay, so sometimes we cannot even say that the zero vector as a vector. So this imply that b vector must be a minus of a vector. Okay, so let's come to this picture. So this is the a vector and this is the minus of a vector, or we can say the b vector. So b vector is nothing but the same a vector but oriented in the opposite direction of a, such that their summation, when we just try to transport it to a, so we will, this is a vector, and we will after adding the minus a to this, we will come to the same point, and resultant vector, there will be only a point, and which is the 0 vector. Okay, so this is the addition properties of the vectors. Now let's come to the multiplication of the vector. The first is the multiplication by an scalar. So let's say we have a vector a, and when we multiply it with a small a scalar, okay, so a is a scalar, right? A belong to a scalar. I think a is a scalar. Okay, so what does it mean? What geometrically a scalar a does to this vector? Actually the a will only change the magnitude of the vector, okay, and the magnitude of the vector in geometrically represented by this length of the arrow. Okay, so if we are multiplying it with a, so a times this a vector will either be a small vector or maybe a large vector, depend upon the value of a. The second property is the dot product of two vector. Okay, okay, one thing that I forgot to mention over here in the multiplication of a scalar is the distributive law. Okay, so in the multiplication of vector by an scalar, there is another law which is called the distributive law. So if we take let's say a scalar a and multiplying with the summation of a and b, this will give the same result as if we are multiplying the scalar a to the vector a and adding with the multiplication or scaling of vector b with an scalar a. So either we will do this or do this, the result will be same. Okay, we can also prove this by geometrically, and this is the distributive law. Okay, now come to the second type of multiplication in a vector that we encounter is the dot product. So we have a vector a dot product with vector b. Okay, so this will actually when we dot product a vector with another vector will actually give a scalar quantity. Okay, so we will not going to get another new vector over here, we will get an scalar quantity. Okay, so numerically they are equal to the magnitude of a multiplied by magnitude of b into cos of theta. So what is this theta? Okay, so we can we will draw a diagram geometrically. We will try to understand what this equation actually means.